Graphing and writing inequalities. An inequality is a statement that two quantities are not equal. You can compare inequalities using different signs. Well, that's kind of just like statement, but let's talk about inequalities in a different way. Okay, you're used to something like this showing up, and you can use it to compare two quantities, right? Like 3 and 8. This says that 3 is less than 8, right? We've seen this in middle school. We've seen this in elementary school. It's the alligator and his mouth eats the bigger number, right? Cool. Well, the great thing about mathematics is that it's a language that typically can be read either left to right or right to left. Okay, we in America, we're used to reading things from left to right, right? We read our books, our sentences from left to right and up and down, right? So we're used to reading this 3 is less than 8. However, not all cultures in the world read things from left to right. You know, they're not going to read this sentence this way. Instead, some cultures will start over here and read backwards, right? Does anybody know of any culture that reads from right to left or maybe up and down or something different than the American culture? Japan. So the Japanese, I believe, they go up and down. So that's how they read. Any other cultures that read right to left? I believe Arabic is read from right to left. Is that correct? I believe Hebrew and the Israeli culture, they read from right to left. Okay? So understand that, you know, it's not all left to right in the world. And in math, it's not all left to right. So what we do is we can read this as 3 is less than 8. If I read this from left to right, less than 8. However, I can read this from right to left and say 8 is bigger than 3, or 8 is greater than 3. Okay? It's important in math to sometimes read things backwards to help you understand what's going on. So, let me write something like this. Here, if I read this statement from left to right, it actually doesn't make too much sense. We say 3 is bigger than x, or 3 is bigger than my number. But what I'm going to want to do in this lesson and in this chapter is read starting with my variable going in the opposite direction. So if my variable is over here, I'd start reading from left to right. But since my variable is over here on the right, I'm going to start from the right and read left. I'm going to say my numbers, or my numbers, are less than 3. Okay? Does everybody see how we can read these inequalities 2 different ways? It's important. Now, so we have our less than from left to right, or our greater than. This is the same thing. It's less than from right to left and greater than from left to right. If we put a line underneath this, okay, it changes it just a little bit. Okay, does anybody know what the line means? Mr. Cummings? Yeah, this line means we could have less than or equal to. Or equal to. Now, I'm not going to say this is a less than symbol. I'm not going to say that because in math you can read things both ways. This is a less than or greater than symbol. However, it's not just a less than or a greater than symbol. It's a less than or greater than or equal to symbol. Okay? Now, let's examine x is less than 3. Both of these are the same. This is x is less than or equal to 3. These are the exact same statement. This looks different because they're backwards. This can be read from left to right. X is less than or equal to 3, or my numbers are less than or equal to 3. However, this is the same thing. Read from right to left, it's our numbers are less than or equal to 3. Okay? Somebody give me some numbers that will make this inequality true. 2. Right? What's another one? 1. Give me another one. 0. I like that, Ms. Jacoby. -6. Give me another one. -7. Oh, way to go crazy, Miss Page. Give me another one, Miss Aaron. 3 works. You said less than or equal to 3, so 3 works. Give me a crazy one, Mr. Smith. -216. Beautiful. Now, what we do is we're going to show all these possible correct answers on a number line. So this is a number line. Okay? And to understand number lines, just know that we have, certain numbers. Since we're kind of focusing around 3, we'll start with 3. We can have numbers that are bigger than 3. They're to the right of 3. Numbers less than 3, they're to the left. Okay? And how we show solutions on number lines is we use these dots. And a dot is like, okay, this could be a possible solution. So I know that 2 is a possible solution. I'll put a dot above 2. I know that 1 is a possible solution. I'll put a dot above 1. I know that 0 is a possible solution. Put a dot above 0. I know 3 is. Put a dot above 3. Okay? I know -216 is. So I can kind of put a dot over here at -216, but I don't have -216. So I guess I'll put a dot there. I don't know. We'll see. Well, are these all my possible solutions? Am I done showing all my solutions? No, Ms. Sanchez. What are some other solutions? Yeah, anything that is less than 3 is a solution. So we should have dots all the way over here and all the way over here. And there's an infinite amount of dots. We can have 2.9999. We have 2.999999. So instead of drawing dots, what should we do? Let's draw a line. Let's draw a line. Let's get this 3 and connect all these dots, and let's just show that we have all these solutions by drawing a line. Let me do that up there, because it's tough to draw lines on this thing. All right, we're drawing a line. This shows all those possible solutions. But what about -216 all the way over there? How can I show that one? An arrow, Mr. Jacoby. Beautiful. An arrow says everything even to the left of that 0 is also a solution. So we draw an arrow. Now, 3 is a possible solution, right? So we should have a big closed circle at 3 showing us that that is our last solution that we can have. Right there at 3. Cool? We have successfully showed all of my possible solutions to this inequality. Cool? All right. Well, how would it change if I had just x is less than 3 or x is less than 3? What's different about this to this? Mr. Moeller. Does it? Let's think. Give me a solution in this situation. X is less than 3. 1. Well, that's like this one up here, right? So if I started with 3, and we had 2, and we had 1, we would have a dot above 1. I don't know if we're going to have a different arrow. I think the arrow is going to point in the same direction. But what's a solution that I have up here that I can't have up here? Mr. Moan. The 3. So our numbers have to be less than 3. And here it was the numbers less than or equal to 3. So we could have 3 because 3 is equal to 3. What is maybe the closest number I can have? The biggest number that I can have? Mr. Stalker? 2.99. Yeah, not just 2. I could have like 2.999 repeated. And that's like right here. Really, really close. So what we're going to do is we're going to show all the solutions that we had up here, all these dots. And instead of drawing all the dots, we're going to just say, well, it's all these shown by this line and this arrow. That arrow will get us to that negative 216 that works. I guess negative 21.6 works as well. But we're going to go up to, but not include 3. To not include 3, what we're going to do is draw an open circle right above 3. This open circle means not including. So we're not including in this situation 3. But we have every single number up to 3. Like 2.999999, 2.9, 2.89. All of these numbers really close to 3 are possible solutions, but 3 isn't, so we say not including 3. Okay? Do you see the difference? Good. Let's move on. It's important, now that we are high school mathematicians, and we are students of the world, not just American students, that we read inequalities either from left to right or from right to left based on where the variable is. For example, my variable over here is on the left. I'm going to read this from left to right. C is less than or equal to 1. That's how I read that. Instead of saying C, I'm going to say that's like my numbers or my solutions. My solutions are less than or equal to 1. Okay? What I'm going to do is start with my number, write a number that is less than, and a number that's greater than. Since it's less than or equal to, since I have this equal to symbol, I will include my solution at 1. And my solutions are less than or equal to 1, or our numbers that I'm looking for are less than or equal to 1. Those numbers are over here. These are numbers less than 1. So my arrow to show those solutions will go over there. Okay, pretty simple. My variable, however, can be on the right side. I would read this from right to left. This would be read, T is less than 2, or my solutions are less than 2, from right to left. I'm not going to rewrite this. I'm not going to just look at the symbol and see which way it's pointed. I'm going to read it from right to left. Well, here's 2. A number less than is 1. A number greater than is 3. This just helps me show my number line. I'm not going to include 2 as my solution because it has to be numbers less than 2. And solutions less than 2 are over here. So even though this is pointed in an opposite direction as this symbol, our arrow is actually going to go the same way because we're reading this from right to left. My solutions are less than 2. Here are numbers less than 2. My solutions are less than 1. Here are numbers less than 1. See how it can work out either way. So for you guys, I want you to do these two. Starting with your number line, what would be a number less than -5? -6, not -4. -4 is actually greater than. Okay? Read this one from right to left. Plot your solutions. Same with this one. I'd start with 4. Read this from right to left. Plot your solutions. Good. Careful. My numbers, my solutions are bigger than -5. My solutions are bigger than -5. Good. Good. All right. All right. We should have an open or closed circle, Miss Davis. A closed circle. And Mr. Gibson, which way does my arrow go? To the right. Reading this from right to left, it says numbers that are bigger than or equal to -5. My solutions are over there. Okay? Miss Gutierrez, open or closed circle for this one? Open. Mr. Rodriguez, to the left or to the right? To the left. My numbers are less than 4. Here are numbers less than 4. All right, what if we have 17/3? How can I show where 17/3 is on my number line? I'm not going to put this is between 18/3 and 16/3. That doesn't help me. I want to put whole numbers. What can I do, Miss Page? Is 17/3 between 16 and 18? Is it between 17 and 18? I don't know. I don't know what 17/3 is. Mr. Stalker? No, don't want to do that. That doesn't help me. I don't know what 17/2 is. I don't know what 17/4 is. What do you think, Mr. Gibson? Yeah, it might not be between 0 and 1. How can I figure out how big this actually is, Mr. Kobe? Yeah, let's change it to a decimal. Let's go into our calculators, and let's figure out how big is 17/3. 5.6 repeated. Now do we know what number this is between, Mr. Kobe? What are the two numbers? Yeah, you could say 5 and 6. You could say 4 and 6. But by plugging that into my calculator, I know that 17/3 is bigger than 5 and smaller than 6. So that's how I do that. And then I read this correctly. My numbers are bigger than 17/3. We're not going to include 17/3, so we have an open circle. And my solutions are over here on the right. Okay? See that? Pretty simple. Just plug it into your calculator. See actually how much we actually have. And then you could even say this is between 4 and 6, but 5 and 6 even works. All right. Do you guys do the remaining 3? 4. When you're done, check your answers with a neighbor. Careful with this one. Read it from right to left. Check your answers with a neighbor when you're done. Careful. Read this one from right to left. W is less than -5. My solutions are less than -5. My solutions are bigger than -3. We're going to go to the right. My solutions are bigger than 27. So that's right. Careful with that one. Good. My solutions are bigger than -3. This is good. Good. That should be a -2, right? Check your number line here. -4/3. -1.3. This is -4/3 this page. So this should be between -1 and -2. -2 is smaller than -1. This is -4/3. -2 is smaller than -1. -2 is smaller than -1. -2 is smaller than -1. You guys did pretty well for the most part. I think a big problem is this one in the middle. And not because of the direction of the arrow or anything, it's because of your number line. We got to talk about our number line a little bit. So let's first do this one. Mr. Miller, closed or open? Yep, closed. And then which direction, Mr. Miller? Exactly. My solutions are bigger than -3. So this is -4, this is -2. Remember, numbers less than, when we're negative, are like bigger numbers, more negative. So we should have -4 and -2. Ms. Zavala, open or closed circle for this one? Closed. And then which way is my arrow going? To the left is correct. Good. My solutions are less than -5. So we should be over here. Number less than would be -6. Number greater than is -4. Now, -4/3, I plug that into my calculator and I figure out that it's like -1.333. So here's -4/3. -1.333. Give me two numbers that's between, Mr. Orsic. -2 and -1. Now, what is smaller than negative 4/3, Mr. Orsick? Negative 2 or negative 1? Negative 2 is correct. Okay, negative 2 is over here on the left. Negative 1 is over here on the right. A lot of people made mistakes on that. You could have put negative 2 and 0 if you wanted to. Those are two numbers. Okay? Now, numbers less than, open or close circle, Mr. Orsick. And then which way is my arrow going? Excellent. Okay? My solutions are less than negative 4/3. Finally, 27ths. We got 2.85. That's between 2 and 3. Okay, that helps you know where it is. Close circle. Mr. Moan, which way is my arrow going? My solutions are bigger than 27ths. Is 3 bigger than 27ths or less than? 3 is bigger, so I should be over here on the right. Okay? If you made mistakes with your arrows, don't try to think about how you did this in middle school or how you did this in elementary school and your teacher taught you, oh, just look at the symbol and then your arrow goes the same way as your symbol. No, that's not the case, especially when we have our variable on the other side. Okay? Commit to reading this as my solutions are blank, 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 and fill in those gaps by reading this correctly. My solutions are less than or equal to negative 5. Okay? Now, I could give you stuff plotted on a number line. And you could write down let's say 0. Let's do one more. 8. Okay? I look at this. I say, okay, all my solutions are over here. All my solutions are less than and not including negative 3. We can say my solutions, x, are less than and not including negative 3. That's one way to write it. What's another way to write it? Mr. Miller? Yeah. If you say it from left to right, you can read this from right to left. X is less than negative 3. Okay? I want you guys to write these statements, and you can use X every time, but I want you to write it both ways, from left to right and from right to left. So this is left to right, this is right to left. Either way is an acceptable answer on a quiz or on a test. You gotta copy them down. Careful. My numbers are greater than 5/3. That's my first one. There's from left to right. and there's from right to left. There's my second one. You got those right? Good. Try the last one as well. Make sure you write it from left to right and from right to left. It's good practice. Math being a universal language, cultures can read math whatever way they want to. Now, so, this arrow's to the left, right? Okay. And we have 8. These represent our solutions, right? So are my solutions less than 8 or bigger than 8? They're less than, because the arrow's over here. Okay? So you start with x. X represents your solutions. So write x. Now, write a statement that says, my solutions are less than 8. My solutions are less than 8. There you go. That's it. Now this one was for that one. Yeah. Now, write this from right to left. Am I out? I think I'm out of tissues. Sorry. All right. Miss Ann, what did you write for your last one? Beautiful. From right to left, this would be 8 is bigger than or equal to x. And Mr. Smith, do it the other way. Beautiful. Okay? Both are correct. All right? Everybody see? Left to right, right to left. We can do either way in math. All right, let's move on. Now we're solving inequalities. Typically, solving an inequality is like solving an equation. So that's kind of what this is supposed to say. Solving inequalities, just like solving an equation. Lots of exclamation points, a happy face, yay, we just did such a good job on our first test on solving an equations. We're really not doing anything that different this time around when we're solving inequalities. For the most part, everything's the same when we're solving inequalities, just like we're solving an equation. First, put an x plus 3 here. And put like an x minus 3. Make that an inequality with a variable. Okay? Mr. Stalker, if I had, instead of a less than symbol, an equals to symbol there. Let's pretend I have an equals to symbol there. And I have x plus 3 is equal to 8. How can I solve this for x? Add the opposite. Am I adding negative 8 or negative 3? Yeah, add negative 3 to both sides, right? And you would get x is equal to 5, right? Well, instead of that equals to symbol, we have this less than symbol. But what's great about inequalities is that the same fundamentals and theorems of things being balanced with equations also apply to inequalities. We can solve them just like equations. So our solutions for x are any number that's less than 5. That would satisfy this inequality. I could plug in 4. 4 plus 3. That's 7. 7 is less than 8. Good. I can plug in 4.99999. 4.99999 plus 3 is 7.99999. That's a little bit less than 8. So we're good there. Okay? If we had x minus 3, what would we do to solve this, Ms. Wells? Yeah. No, add 3, add the opposite. I screwed you up by making this plus a negative. Since the rules still apply with things being balanced in inequalities, boom, we get our answer. My solutions are numbers less than 11. Okay? So you know how to solve equations. Now you know how to solve inequalities. It's pretty much the same. The only difference is, after we solve an inequality, like this one, I would add -9 to both sides. We're going to have to show all of our possible solutions. So we don't just have one solution, like 6 or something. We have an infinite amount of solutions. We have all of these numbers that are less than 6 are possible solutions. So we're going to use this number line to show all those solutions. And it turns out every single number up to, but not including 6, is a possible solution to this inequality. Cool? So that's how we show it. All of these numbers right to the left of 6, and then all the way over here in the negatives, those all will work here. Those are all possible solutions to this inequality. We don't just have one, we have an infinite. Okay? Sounds good? Well, why don't you guys, I'll do the second one just to show you. There's my variable d. What's bothering my variable? -3. I add the opposite to get rid of it. I get -3 is less than or equal to d. Well, here's -3. A number less than would need to be -4. A number greater than is -2. Numbers bigger than or equal to -3. So we're going to include -3. I read this from right to left. Numbers, solutions are bigger than or equal to -3. Here are my solutions to the right. See that? Okay, do the remaining 4. Remember, if you got stuff on the same side, combine. Same side, combine. Careful with this. My solutions are less than or equal to -6. -4 plus -2, that's -6. I'm waiting for your arrow. Read it from right to left. Don't look, just read. Just read. My solutions are blank to -6. Nope. My solutions are less than -6. What's -4 minus 2? It's not -4. That's the same thing as that. So I say, change it to add the opposite. You won't get confused. Careful with your arrows. Read it in the correct direction. Good. Check your answers with neighbors. Do the last one. You guys checking answers? You get the same thing for everything? Cool. That's good. That's great. Fantastic. What do we do to the first one on this page? What'd you do to solve for n here? What? Yeah, good. Okay. Remember, just to remind those, and for those of you not here the first week of school, when we see subtraction, it's the same as add the opposite. So n minus 4 is the same as n plus a negative 4. This negative 4 is bothering n. To get rid of stuff being added, you add the opposite. I add 4 to both sides so that I can get n by itself. N is less than 11. Mr. Kobe, which way is my arrow going? To the left. Correct. I read this from right to left. Numbers less than 11. There are my numbers less than 11. Those are my solutions. Next one, I should add the 3 and the 4 first. Same side combined. Now I got to get rid of this negative 2. To get rid of something being added or subtracted, you add the opposite. I'm going to add 2 to both sides. I get 9, my symbol, and T. Numbers greater than 9. Here's 9. I should have an open circle, and my arrow should be to the right. Here, I would add negative 2 to get rid of this 2. Negative 4 plus negative 2 is negative 6. I have numbers less than or equal to negative 6. Here's negative 6. I'm going to include negative 6. Numbers less than negative 6 are over here, where negative 7 is, not where negative 5 is. Okay, 9 being between 8 and 10. Finally, to get rid of negative 2, that's bothering R, I add 2. R is greater than or equal to 7. My solutions will include 7. 7 will work. 7 plus negative 2 is 5. 5 is greater than or equal to 5. But then every single number bigger than 7 also works. Where 8 is, not where 6 is. Cool? All right. Do this first one. Actually, no, do the second one. Practice adding fractions using your calculator. Use parentheses around your fractions, please. Figure out what your number is between. Draw your arrow correctly. And just a public service announcement, if you ever miss a class, you're responsible for watching the video of the lecture that you missed and doing the homework that corresponds with that and showing up to class ready to take the next quiz. Okay? There's never a day that I'm going to give you a free pass and say, oh, no, you don't have to take this. You will always keep up with the class because I give you the opportunity to keep up with the class. Add 5 6 to both sides. To add fractions in my calculator, knowing that 2/3 is like a division problem. 2/3 is like 2 divided by 3. 2/3 I can type in like that. I add 5 6. Add 5 divided by 6. Your calculator gives you the correct answer. 1.5, that's the same as 3/2. If I change that to a fraction, I go math, enter, enter. That's 3/2. But since it's a finite decimal, that's fine for your answer. 1.5 is between 1 and 2. My solutions are bigger than or equal to 1.5. So I should have a closed circle, and my arrow should be going which way, Miss Krieg? The right. Okay, that's fine. Cool. All right, let's move on. Now, I said for the most part, everything's the same when we're solving inequalities. It's the same as solving equations. We can add, we add the opposite. We're going to be able to divide here. However, there's going to be a catch. Okay? So, change this -3 to a +3 real quick. Okay? Change this -3 to a +3. I want you guys to just give me some answers for x in this situation. What numbers can I multiply by -1 to be less than or equal to 3? Ms. Cordova, give me one. 2. 2 times -1 is -2. -2 is less than or equal to 3. Give me another one. Mr. Cardenas. 1. 1 times -1 is -1. -1 is less than or equal to 3. Give me another one, Miss Aaron. 0 times -1 is 0. That's less than or equal to 3. Mr. Smith, give me a crazy one. 18. 18 times a negative makes this negative. That's less than or equal to 3. Okay? Cool? 200. What about the smallest one? We have all these numbers that are bigger here. We have numbers getting smaller. What is a small number, Ms. Jacoby? -2. -2 times -1. That's less than or equal to 3. That's 2. 2 is less than or equal to 3. Mr. Smith? -3 would be our smallest. Could we have a biggest solution? Give me the biggest solution, Mr. Stalker. Why not? Yeah, we can just have numbers like 1,000. That times a negative makes it a solution. 1,000,000, a jillion, a kabillion, whatever. A Google. You know what a Google is? 1 followed by 100 zeros. It's 10 to the 100th power. It's an actual number, a Google. That's why they came up with the website Google, because it's like a huge number. Okay? So, that's the small. Let's look at this situation. 3 times x is less than or equal to 9. Give me solutions for this. Is there a biggest solution or a small solution? What is it, Miss Wells? This one. Give me the biggest solution you think you can get. 3. 3 times 3 is 9. Is there any numbers that are bigger that will work? Does 4 work, Miss Jacoby? No, if I plug in 4, I get 12. 12 is not less than 9. So it turns out that's the biggest. Interesting. So like we could have 2, we could have 1, we could have -1,000. Those all would work, right? All right, so we're looking for these values when we solve. Let's see. if I solve this like I normally would, okay, what would I do? Divide by -1, right, Mr. Jacoby? -1 is bothering my x. To get rid of it, I'd divide, right? We would get x, and this would be -3, right? Well, if I did the same stuff like I did when I was adding and subtracting, this would be less than or equal to, right? Right? We divide by -1. We get x is less than or equal to -3. Well, some numbers that are less than or equal to -3, -4, right? -5, -6. Are those solutions? Is -4 a number I could have put up here? We were told that -3 is the smallest. So is this correct? Mr. Jacoby, is that correct? No, this isn't correct. Numbers less than or equal to -3 don't work. -3 is the smallest. We want numbers bigger than -3, right? So this is wrong. Okay, but let's try this one. Maybe this one will work. How do I solve for x here, Ms. Krieg? Yep, divide by the same. And I get x is less than or equal to 3. Okay. Now, let's look. We were told 3 is the biggest. 2, 1, -1,000. Those are all solutions. Is this correct then? Ms. Cordova, is this correct? This is correct, actually. Numbers less than or equal to 3. These are all numbers less than or equal to 3. So this is correct. But this one was incorrect. What would have made this one correct? This is like thinking here, guys. We're going to have to do it sometimes. What could I change here to make this correct? So if I made it +3, numbers less than or equal to +3, well, let's see. No, I could have like -4. We were told that -3 was our smallest solution here. What could I change, Ms. Cordova? Make this positive? The -1, make it a +1, then divide? Like, that would change my equation. That would kind of mess with stuff. Mr. Orsic? Now, let's see, if I flipped this and made it a greater than or equal to, well, this is our smallest. These are all numbers bigger than or equal to -3. This works. Do we have to change this? No, this is good. So, what do you think the only special rule is when we're solving inequalities? What's different about this problem from this problem? We're dividing, right? That's the same, but what's different, Miss Aaron? Yeah, we had a negative here that was being multiplied by my variable. If we divide by a negative, we're going to have to flip our sign. If we divide by a positive, we're good. Nothing has to change. That's the special rule. If you divide or multiply by a negative, you must flip your sign. Write that down. Mr. Stalker.
If you flip the sign and it has a equal underneath it,
you
keep it?
Well, the equal stays, yes.
Okay.
But you would just flip this. Okay? When you divide by a positive, don't change anything. Everything's fine. But when you divide by a negative, you must flip your sign. We had to flip. In this situation, do not flip. In this situation. Okay? So, for example, this second one I'm going to do. -2/3 is being multiplied by x. To solve, I would divide both sides by -2/3. when I do that, 6 divided by, in parentheses, I must put negative 2/3. I get negative 9. However, since I divided by a negative, I must flip my symbol. Okay, this becomes numbers less than or equal to negative 9. Put a closed circle over negative 9. My solutions are less than or equal to negative 9. My solutions are to the left. All right. Here, how do I solve for x here? Mr. I haven't called on yet. Mr. Cummings, I'll call on you. How do I solve for x in this situation? Divide by 3. Now, negative 27 divided by 3 is negative 9. Do I flip my sign? Mr. Cummings? What's that?
No.
I do not, because I'm dividing by a positive. Doesn't matter that this ends up being negative. I do not flip, because I'm dividing by a positive. And we just have x is less than negative 9. Open circle, arrow to the left. Now do me a favor, do the remaining 4, but change this negative 5 to a positive 5. Right here. Change that to a positive 5. All right, do the remaining 4. Flip when you should, do not flip when you shouldn't. You divide or multiply by a negative, you flip. You divide or multiply by a positive, you do not flip. Not about what you get, it's about what you divide or multiply by. Thank you, sir. Do you have your review as well, Mr. Dishram? I'll have the video for this lecture up this afternoon, so you can watch that. Take the quiz next class. Good. When you divide by a negative, you have to flip. If you divide both sides by a negative, like we did here, you must flip your symbol. Okay, we should have flipped here, we should flip here. Do not flip here and flip here. We had to divide by negative 1. We had to multiply by positive 5, divide by negative 8, divide by negative 4. Make sure you remember these for your homework. I'll see you guys on Wednesday. We'll have a quiz. Do your homework. Thank you. Please return your